question says that a block weighing 10 Newton travels down a smooth curved track AB joined to a rough horizontal surface. That means this is frictionless and this part after B does have friction, and the rough surface has the friction coefficient of 0.2. That means mu is given to us, that is 0.2. If the block starts slipping on the track from a point 1 meter above the horizontal surface, then it would move a distance s on the rough surface. So if it starts from this point 1 meter above the ground, it travels a certain distance and then it travels another distance s over this rough horizontal surface. We have to calculate the distance that this block will move on the rough horizontal surface before coming to rest, because we know that on the surface we've got friction. Friction is going to oppose the motion of the block and it will eventually come to rest, and we have to find the distance on this horizontal plane over which this block is going to come to rest. Now, for this, we basically use the work-energy theorem, which states that the work done by all of the forces is, they can be conservative or they can be non-conservative. It's going to be equal to the change in kinetic energy. So, by work-energy theorem, we know that the first force, a conservative force acting here, is gravity. So, gravity, we know it's going to act downwards, and its formula is mg, and it's going to displace this block over a displacement over a height of h. So mgh. And talking about the sign, we know that gravity is acting downwards and displacement of this block is also downwards. So it's going to act in a positive direction. Apart from this conservative force, we also have friction, which is a non-conservative force acting in this particular direction. So we know that friction, and since it is a resistive force, we'll always put a negative sign before it. And we know that friction equals mu times normal, and normal is mg. So mu times mg multiplied by the distance that it covers, which is this distance s, and after the distance s, it comes to rest. So the work done by both of these forces in the entire system is going to be equal to the change in kinetic energy. And change in kinetic energy is going to be half mv square minus u square. Putting in the values, we have mass of the block given as 1 and the weight of the block given as 10 Newton. So mg is going to be 10 and it's going to travel through a height of 1 meter. So it's going to be 1. We are given with the coefficient of friction over this rough surface, that is 0.2. And again, it is going to be 10 and we have to find S. Now when we talk about this change in kinetic energy, initially the block was at rest and finally the block is at rest. So V is going to be 0 in both of these cases. Since V is 0, the entire term becomes 0. So 10 equals 2 times S. S equals 10 upon 2 and S equals 5 meters. Hence, this block travels 5 meters on the rough plane before coming to rest.